Welcome to the new video, where we'll learn about VMware networking. Imagine you're a network engineer with 15 years of Cisco experience. You've configured hundreds of switches, thousands of VLANs, and solved complex network outages. Then one day you open VMware vSphere, and suddenly nothing makes sense. No physical switches, no familiar interfaces, just vSwitches, port groups, vMkernel adapters, and something called a distributed switch. At first glance, it feels like VMware created an entirely new networking model. But here's the truth. VMware didn't change networking. It changed where networking happens. By the end of this video, you'll have a simple mental model that makes VMware networking finally click. The first reason VMware networking feels confusing is because traditional networking assumptions no longer apply. What if everything you know about networking is still correct, but implemented differently? In the physical world, networking revolves around switches, ports, cables, and VLANs. Inside VMware, you see vSwitches, port groups, vMkernel adapters, and distributed switches. The challenge isn't learning new concepts. The challenge is understanding how familiar concepts are virtualized. The names sound familiar, but the behavior isn't always identical. That's why experienced network engineers often feel like beginners when they first enter VMware environments. And the biggest confusion starts with the most basic networking component, the switch itself.
Where is the switch? In traditional networking, the switch is a physical device sitting inside a rack. You can see it, touch it, and connect cables to it. In VMware, the switch exists entirely in software. The vSwitch lives inside the ESXi hypervisor and performs Layer 2 switching functions without requiring dedicated hardware. Many engineers spend their first few days looking for a switch that simply doesn't exist. The switch didn't disappear. It moved inside the server. Once engineers understand the virtual switch, they run into another confusing object, the port group. Is a port group just another name for a VLAN? This is one of the most common misconceptions in VMware. A port group is not a switch, it's not a subnet, and it's not a VLAN. A port group is a logical connectivity template where policies are applied. Yes, it often contains a VLAN assignment, but it can also define security settings, traffic shaping policies, and NIC teaming behavior. Think of it as the connection profile that virtual machines inherit when they connect. And VMware doesn't stop there. It also changes how physical network connections are used.
What if one network cable carried almost everything? In traditional environments, management traffic, storage traffic, and server traffic are often separated onto dedicated networks. VMware takes a different approach. The same physical uplinks can simultaneously carry VM traffic, management traffic, vMotion traffic, and storage traffic. Through VLAN tagging and policy-based separation, multiple logical networks share the same physical infrastructure. To a traditional network engineer, this can feel risky at first. But this convergence is one of the reasons virtualization is so efficient. And that leads us to the most misunderstood networking component inside ESXi. What exactly is a vMkernel adapter? Many engineers assume vMkernel adapters are used by virtual machines. They're not. vMkernel adapters are used by ESXi itself. Need management access? vMkernel. Need vMotion? vMkernel. Need iSCSI connectivity? vMkernel. Need vSAN communication? vMkernel. Think of vMkernel adapters as the network identity of the hypervisor. They're how ESXi communicates with the rest of the infrastructure. Misunderstanding vMkernel adapters often causes one of VMware's most frustrating troubleshooting scenarios. Why does ping work perfectly while vMotion keeps failing? This happens more often than you'd think. The VLAN is correct, hosts can each other ping, basic connectivity exists, yet vMotion refuses to migrate virtual machines. The reason is simple. vMotion requires a properly configured vMkernel adapter with the vMotion service enabled. connectivity alone isn't enough. VMware services depend on proper service bindings and vMkernel configuration. And just when you've mastered that, VMware introduces another layer of abstraction. What if one switch could manage networking across an entire cluster? That's exactly what a VMware distributed switch does. Instead of configuring networking host by host, administrators define networking once inside vCenter. Those configurations are then applied consistently across multiple ESXi hosts. VLANs, security policies, uplinks, and traffic settings all remain standardized. If you've worked with switch stacks before, the idea feels familiar. But now the control plane is entirely software-driven. And this centralized model enables something that traditional networking rarely experiences. What happens when a server moves without changing its identity? In traditional environments, MAC addresses are often associated with a physical location. VMware changes that assumption. Using vMotion, a running virtual machine can move from one ESXi host to another. The VM keeps the same MAC address. The VM keeps the same IP address. The VM keeps running. Only its physical location changes. The network must quickly adapt and learn the new path. That's why VMware networking behaves differently than many engineers expect. To understand this mobility, we need to follow the journey of a packet. Let's trace a packet from a virtual machine all the way to the physical network. The journey begins inside a virtual machine. The packet enters the port group, where networking policies are applied. From there, it reaches the vSwitch or distributed switch. The switch forwards the packet toward a physical uplink. The uplink sends the traffic out through the VMNIC adapter. Finally, the packet reaches the physical switch and continues through the network. Once you visualize this path, VMware networking becomes much easier to troubleshoot. And understanding this path helps explain why most VMware networking problems occur. Most VMware outages are surprisingly simple mistakes. A VM gets connected to the wrong port group, a VLAN ID is configured incorrectly, an uplink is disconnected, NIC teaming settings don't match the physical switch configuration, or a vMkernel adapter is misconfigured. These small configuration mistakes often create major connectivity problems. The good news is that once you understand the architecture, troubleshooting becomes much faster. So what's the easiest way to remember all these VMware networking concepts? Here's the mental model that makes everything click. Think of a physical switch as a vSwitch. Think of a network interface as a vMkernel adapter. Think of VLAN assignments as being applied through port groups. Think of a switch stack as a distributed switch. The concepts themselves haven't changed. Only the implementation has changed. Once you translate VMware terminology into familiar networking concepts, everything starts making sense. And that's exactly how enterprise architects think about VMware networking. VMware didn't reinvent networking, it virtualized networking. The same principles still apply. Frames are switched, VLANs still separate traffic, MAC addresses still identify devices. Routing, security, and network design still matter. The difference is that software now performs functions that previously required dedicated hardware. Once you stop searching for physical devices and start thinking in terms of logical services, VMware networking becomes surprisingly intuitive. Let's wrap everything up with the most important takeaway. So what's the one lesson to remember? The next time VMware networking looks confusing, remember this. You're not learning networking again. You're learning how networking behaves when the switch becomes software. Once you understand vSwitches, port groups, vMkernel adapters, distributed switches, and packet flow, the entire architecture becomes much easier to understand. If this video helped simplify VMware networking for you, please like the video, subscribe for more VMware deep dives, and comment below with the next VMware topic you'd like me to explain. Because in VMware, the network didn't disappear. It simply moved inside the hypervisor.